Greetings to all of you friends. Welcome to course on micro irrigation. Today in this lecture what we are going to cover is water resources planning for irrigation with specific reference to micro irrigation systems. Here what you would understand as we proceed that as far as uh, water requirement for irrigation is concerned, there is a similar procedure whether we work out water requirement for conventional systems or for micro irrigation systems. Here I am Virendra Sharma. This is my brief introduction. So as far as presentation sequence is concerned, the presentation covers all major consideration of water planning for irrigation, including of course those for micro irrigation systems. Various issues which we are going to cover in the presentation are checking on resource availability, crop planning, reference evapotranspiration, crop water requirement, that is net irrigation requirement, after consideration of other requirements other than crop water requirement. Then water use efficiencies, what are the various efficiencies we need to cover and how they are estimated for working out the net irrigation requirements and gross irrigation requirements. Then demand table at source, so wherever we are sourcing water to be provided for irrigation, so what is the demand at source for various requirements of various fields, various crops grown there, sum total of that, so that on a discharge basis. Discharge means per unit consumption or requirement basis, so that will be our demand at source. And what would be the required capacity, carrying capacity of the system, whether it is a canal system or a pipe distribution system, which we would need to provide at the source. Then also there will be a brief introduction on some softwares, open source software uh, which are provided at FAO site, and those are also good to use and can give quick estimation of crop water requirement. And also a source on open source software on ClimVat, that is a software which gives us climatological data for at a particular given location. In irrigation planning, we take into consideration what are the existing and proposed irrigation facilities, because that would give us some ideas that where are the areas which, what are the irrigation facilities if we want to modify them or provide to areas which are not covered by existing irrigation facilities. So, and the existing area under rainfed cultivation, that we also need to know, because that is the area which we would like to convert into assured irrigation, receiving assured irrigation. And then there are estimation of areas, that is gross command area. Gross command area is actually the geographical area wherein we are planning to provide irrigation, and culturable command area is the one if we remove the areas for other utilities, that like the areas for roads, canals, and maybe the areas which are inhabited by population. So any area which is can be used for cultivation is a culturable command area. And then also we would like to know what is the rainfall data of that area, because we know that if there is a rainfall, then a part of the water is going to be contributed by rainfall, and the remaining part, all which a crop would be requiring, we would need to provide from irrigation. And then we need to know what is the cropping pattern, like what is the existing cropping pattern, because the existing cropping pattern is important from the point of view that what are the existing crops which are being grown successfully and which are suitable to the crop, and that agroclimatic region or area which with agroclimatic conditions of that area which are supporting those crops. So existing cropping pattern is very important for deciding on what should be our cropping pattern, which we need to provide as a project cropping pattern, and the one which we would be planning and estimating to support through our irrigation system. Then what is the irrigation intensity? Irrigation intensity in the sense that what would be the total area which we would be covering in different uh, croppings, like we may have 2 or 3 croppings within the same area. I mean, some crop grown in some months, like say May, June, July, then sometime we may have another crop in the same area from August, September, October, November, like that. So on the same area we can have number of crops. So based on what is the total area which we would be covering, considering uh, cropping at a particular time, uh, we will be counting it thrice. If same area we are getting 3 crops, we will have to count it thrice. So any area which we would be covering through different crops at different times of the year, divided by the cultural command area, that would give us intensity of irrigation. Now what is the water availability? If it is there are any surface irrigation facilities, I mean that we have some reservoirs or maybe river streams which would provide surface water, so that we need to take into consideration, and also amount of water which we propose to use for irrigation out of that availability of surface irrigation. Then irrigation planning would also take into consideration crop water requirement, so that we have to estimate what is the crop water requirements. And as we know that crop water requirement would depend upon what type of crops we are taking, and also where in the geographical area we are planning to have those crops, because every geographical area would have a different climatological conditions, and accordingly the same crop grown in different areas would have different crop water requirements. So there are 2 components: one is crop, and another is in what area we are wanting to grow the crop. So these are the 2 considerations. As we proceed, we would be able to know that how these are taken into consideration. Then what are the efficiencies assumed? So I mean, there are various ways, like uh, in case of conventional systems, there, if it is a canal system, it could be a lined canal, partially lined canal, uh, or you say fully canal lined canal, or there could be a pipe distribution system. So based on that, there would be certain canal conveyance efficiencies, and if we are using uh, whether we are using conventional irrigation methods, there would be certain application efficiencies, and similarly if we are using drip or sprinkler, there would be some certain efficiencies associated with them which we would assume and take into account while working out groundwater requirements. Then sometime if it is a big project or reasonably big project, then we do take into account from source what are the requirements, other requirements other than irrigation, like drinking water, or sometime a nearby industry may also need to be provided. So accordingly, for planning the water at source, these kind of requirements may also be taken into consideration. Then success of the scheme, any irrigation project is considered successful if in 3 out of 4 years we are able to fulfill our demands and we are able to grow our planned crops in the fashion which we have planned. So if we are successful in 3 out of 4 years, that is we are 75% successful, then the project is considered successful. And also we need to have an assessment of groundwater availability, what kind of annual drafts are available based on the groundwater data. So all these we need to take into consideration for irrigation planning. Now this, you see a schematic diagram. If we see this, then it is a system based on surface irrigation, wherein we see that this is a structure which is constructed across this river stream, and this is the catchment area which may result into, if it is a storage project, a reservoir would be created somewhere here, and if it is a diversion project, maybe there would be some pondage and the water will be diverted to these two directions. And there are main canals, then there are further distributaries, and there would be further distribution of the canal system. And similarly, if it is a pipe system, these canals would be replaced by a set of pipes which would be carrying water from this and then delivering to the fields and the command. Now resource availability, if we consider for crop, there are two critical resources, water resources and land resources, and both of them put together results into irrigated agriculture. And we must understand that a proper investigation of the resource, may it be land resource and water resource, is exceptionally essential, and that only can lead to the right kind of planning and right kind of success and achievements as far as irrigation planning is concerned. Now water resources, there could be based on surface water, or it could be based on groundwater, or it could be a integration or conjunction of both the surface and groundwater. In case of surface water, if we are planning, we need to obtain long-term data of rainfall and inflow of the river stream. Then the data requirement, if it is a storage projects, we need a monthly yield series for 20 to 40 years, and if it is a diversion scheme, we need a 10 daily series for 20 years or so. For groundwater resources, we need to monitor pre and post groundwater monsoon data, post monsoon groundwater levels. Then we need to assess water availability in terms of what is the draft that is available annually, which can be extracted without affecting the groundwater levels. Then we can plan conjunctive use of groundwater available based on the assessed annual groundwater draft which is sustainably available. Then once the project, if it is a groundwater project or maybe a conjunctive project with the use of both ground and surface, then also we need to monitor the groundwater level so that we can monitor that our use for irrigation is not uh, affecting the groundwater sustainability of groundwater, and the groundwater levels are stable and they are not going down. Land resources in command area, we need to collect the right kind of land use data, assess what is the ground gross command area and culturable command area carefully, and accurate inaccurate assessment of culturable command area can lead to unnecessary extension of command if we have underestimated, and there could be a curtailment of command if we have overestimated that area. We may not be able to feed the entire command. Soil survey, helps in identifying suitability of soil for irrigation. Soil survey is essential as entire irrigation planning depends upon it. you know Soil survey is basically we are uh, surveying the characteristics of soil as to what kind of soil is there, what kind of crops it can support, and what kind of uh, water retention capacities and other things are there. So these are the things which inputs are provided by soil survey, and these soil surveys help us in correct decision about optimum cropping pattern. Carry out either carry out a semi-detailed soil survey or use such information if that is readily available. If somebody else has done that soil survey, some agriculture university or some other research institute has done that survey, so those inputs can be used for deciding on cropping pattern and other planning of facilities. The cropping pattern should be decided keeping in view agroclimatic zones, what kind of agroclimatic zones are there and what kind of crops are supported in that agroclimatic zones. Then what are the soils available in the command area, because by this you can understand that what kind of crops would be supported by that uh, kind of soils. Then the present cropping pattern of command and the neighborhood, because the time is the best judge. So whatever crops have been traditionally grown in that area would be going to be definitely supported in future also. So most of the cropping pattern should depend upon what has been the cropping pattern in that area and the neighborhood. Then quantity of water available may also influence the proposed cropping pattern, because sometimes if abundant water is available, you can think of growing crops which you can support through that abundance of water. But sometimes if the water is scarce, then maybe you need to restrict to the crops which require less water, and those would be the ones which you would be planning in your cropping pattern. CWC has come up with guidelines for less water consuming cropping pattern for irrigation systems in drought prone areas, and the link is provided. You see, this is the link which has been provided, which can be downloaded and referred if you are in an area which is drought prone and where you need to plant crops with very less water consuming crops. Then this guidelines provide information about type of crop that are suitable under different rainfall and water availability conditions and cropping pattern for different agroclimatic zones. Now in working out water demands, our primary requirement is the water demand for irrigation, and for this estimating crop water and irrigation requirement for proposed cropping pattern is the principal parameter for planning, design and operation of the irrigation systems, is essential for assessing the adequacy of water resources, for evaluating the need of storage reservoirs and for determining the capacity of irrigation systems. So once we know what is our demand through computations of crop water requirements for all the crops and all the area which we plan to cover, we will be able to work out what would be the volumes and discharge of water that would be required by us, and so that would help us in determining what kind of storages we would be requiring and what kind of capacities of irrigation systems we would be requiring. And again, incorrect estimation may lead to serious failures, so estimation has to be very good and real. Now as far as irrigation requirement is concerned, broadly we see that net irrigation requirement is ET crop, that is crop water requirement, actual crop water requirement of the crop, minus dependable effective rainfall, because part of that is being contributed by effective rainfall. Then there could be some contribution from groundwater if the water tables are not reasonably down, and then there could be some water that could be stored in soils at the beginning of the period, so that would also provide some contribution. And then there could be leaching requirement. So all these put together, that is evapot water requirement of the crop minus the contributions plus the leaching requirement, that would give us the net irrigation requirement. Now crop water requirements or crop evapotranspiration. What is the crop water requirement? That is the actually water used by crop for evapotranspiration. A part of it would be directly evaporating from the surface near crop, and part of it would be used by crop for photosynthesis, and part of it would be then getting evaporated through the crop body, that is stem and leaves. So both of these evaporations and transpiration, it will count, it is indicated, or it is named as crop evapotranspiration. So that is what amount of water used by growing plant to meet evapotranspiration needs. So evaporation needs and transpiration needs. Then crop evapotranspiration is computed. How it is computed? It is computed by multiplying the crop coefficient with the reference evapotranspiration. Now you see, the crop water requirement depends upon two things, as I just mentioned at the beginning also, that what is the crop, because it is a property of a crop and also a property of the geography where that crop is grown. So if as far as the reference evapotranspiration is concerned, it is basically the transpiration transpiration which is computed based on climatological data of a particular geographical location. So I mean there would be different evapotranspiration reference evapotranspiration for different geographies on the globe. And when we take into account the crop and how the crop is taken into account, it is taken into account through crop coefficients. So different crops will have different coefficients. So at any place, the evapotranspiration, when it is multiplied by crop coefficient, it gives evapotranspiration of that particular crop. So again you see that from geographical area A to geographical area B, there could be a different reference evapotranspiration. But if the same crop is grown at different geographies, it will have different crop evapotranspiration, because the reference evapotranspiration itself is different. So when we multiply reference evapotranspiration with crop coefficient for a particular crop, it gives crop water requirement for that particular area, for that particular crop for which we have used that coefficient. So based on this, for any location wherever we are planning our irrigation, so we have to first work out reference evapotranspiration of that area. That reference evapotranspiration would be having different values during different time of the year also. So based on that, we will work out reference evapotranspiration maybe monthly basis. So, and crop coefficient will also vary based on the period of the growth of the crop. So that this we will take up in coming slides. So broadly we see that at any given point of time, what crop evapotranspiration is reference evapotranspiration into the coefficient of that crop. Now as far as reference crop crop water requirement is concerned, there are various methods. There are certain empirical methods, some correlations between evaporation data, radiation data, and the crop water requirement. So the various methods are Blanley-Cradle method. This is basically an empirical formula developed by Blanley-Cradle. There is a radiation method, so which is a radiation at any given point of time is directly correlated with crop water requirements. Similarly, pan evaporation at different time at a particular location is again correlated with crop water requirement, and then there are methods which have been more frequently used, like modified Penman method, which gives reasonably good results in tropical climates and still in use in India. However, it overestimates ET0 by up to 20% for low evaporative demands. Then there is a latest Penman-Montague method, which has been recommended by FAO, and FAO has accordingly developed some softwares also for use of this method. Now what is modified Penman method? It is a method which is again based on reference evapotranspiration computations and then using the crop coefficients, and this method is mostly used in India, and CWC Longback under Water Management Division of Ministry of Water Resources had developed a guide for estimating water requirements, and that guide is useful as far as computation of modified Penman method is concerned. Here again, the climatological data like temperature, sunshine, humidity, wind speed, latitude, rainfall, these are requirements, and based on the climatological data, the reference evapotranspiration is computed. The detailed method is provided in the guide. And reference evapotranspiration can also be used from relevant IMD publications. Sometimes Indian Meteorological Department has worked out reference evapotranspirations for different stations in the country, and any station which is nearby the area which we are planning for computing crop water requirement, that can be used for picking the value of reference evapotranspiration. Now, as far as crop coefficients are concerned, you see that they are not fixed during the entire stage of development of the crop. Initially, you see there is a lower value, and then it increases during the crop development stage, and during the mid stage it is maximum. Then in the late season it is again dropping down, and at the time of harvest it has got certain other value. So it depends upon the length of the crop development stage, and table 27 of the guide of estimating crop water requirement provide the value of Kc at different crop stages for different crops, so that can be used for computing crop requirement. Then crop evapotranspiration is computed by multiplying crop coefficients with the reference evapotranspiration, as we have already discussed and deliberated in detail also. Then Kc values takes into account the crop characteristics, time of planting or sowing, stages of crop development, etc. Now this we have already told that table 27 of the guide provides the crop coefficients at different crop stages. Then another important thing which we would like to know is what is the effective rainfall, which means part requirement of consumptive use of crops, because sometime when there is a rainfall, the entire water would not be available for use by the crop. So that part of the rainfall which is usable by crop is effective rainfall. And the relationship between effective rainfall, the variable factors like total rainfall, consumptive use, net irrigation application is illustrated in table 10 of the technical series 2. So those that table, once we know some of these data for a corresponding crop and the rainfall data, so based on that normal rainfall data and the other data, that is consumptive use or net irrigation application, we can get the what is the effective rainfall. So that effective rainfall will contribute to part of the crop water requirement. Now if in countries like India there is a crop paddy which requires a constant ponded level, and which results into some deep percolation losses, and those deep percolation losses are happening, and those water which is not being used by crop and it is simply uh, getting deep percolated. But as far as for providing for irrigation for this maintaining this ponded level, we need to have some provision. So in generally if it is there's a variation of 2 mm per day to 6 mm per day based on whether it is a clay soil or sandy soil or whatever type of soils. So wherever the soil permeability uh, comes into play, we need to assess what kind of percolation losses we need to consider. Now here is a simple calculation. Wheat is the wheat crop has been considered, then crop duration has been considered from mid November to March, and these ET0 values have been put for a particular place, that is per day. And then there are crop coefficient. These values are based on what are the initial stages, development stages, mid stages, then late development stage, and then harvest. So based on these values, how do we compute the water requirement for crop? Here you see these months have been divided into fortnights. Then ET0 value, those were per day. So if we multiply them by number of days, we get this ET0 value in millimeters of depth. So that would be ET0 values corresponding to those periods, those fortnights of the months. Then accordingly we put what are the crop coefficient values depending upon the stage of development of the crop. Then ET0 value, when we multiply by this, we get ET crop. So that is the crop evapotranspiration requirement or crop water requirement during those period of month or those fortnights. And this value you see is in depth of water. So I mean, whatever is the area which we are growing for that crop, so if we multiply by that, then that could give you the crop water requirement in terms of volumes of water. But before that, we need to consider if there are any percolations, we have to add the percolation requirement for paddy, and if it is not, otherwise we'll not consider these values, and then we will work out what is the effective rainfall based on the normal rainfall of that region. So these effective rainfalls will be deducted from the crop water requirement to work out what is the net irrigation requirement during these fortnights for wheat in depth of water. So this is the net irrigation requirement in terms of depth of water required, and if we multiply this by the area which we need to work out for, which we are planning to provide to that crop, so that would give you the net irrigation requirement in terms of volumes of waters, or if we further divide it into time, we will be able to work out what is the discharge of water that would be required to provide that water on a uniform basis. So I mean, this is how we work out crop water requirement for one crop. Similarly, if we have n number of crops, if there are 10 crops or 5 crops or 6 crops to be grown in the area or in our command to be fed from our system, we need to work out for each one of them according and also work out what is the water requirement during various fortnights or 10 days or months, and then we have to consider what are the other losses, because these were all requirement net irrigation requirements. Then if we add losses to them, losses could be in application or conveyance, then we will be able to find out what are the gross irrigation requirements. Irrigation efficiencies account for losses in conveyance and field application. Now irrigation efficiencies or the total project efficiencies would be volume of water delivered to the root zone, that is the main water that is required for crop evapotranspiration, divided by volume of water released from source. So that will be total water required in the root zone plus all water losses that would provide the volume of water released from source. Now conveyance efficiencies depend upon extent and type of lining. If it is a surface irrigation system, It can be split up into loss of source from canal head to outlet and loss from outlet to subsystem. Conveyance efficiency, we see that what is conveyance efficiency? It is volume of water delivered to the field divided by volume of water released at source. So any water which is efficiency of water in carrying the water from source to the field. So that gives us conveyance efficiency. Field application efficiency takes into account loss due to evaporation and water remaining unutilized, excess application that also uh, would result into some kind of loss. Then field application efficiency is basically volume of water delivered to the root zone to volume of water drawn at the field system. Now field irrigation requirements are worked out by dividing net irrigation requirement from field application efficiencies, and gross irrigation requirements are worked out by dividing field irrigation requirements by conveyance efficiencies. And if we do that, we get the gross irrigation requirements of different crops during different periods, and those, if we put together for all the crops for different areas covered by them, what we will be able to prepare would be a demand table showing monthly or 10 daily demand for all the crops for all 12 months. Now this demand needs to be matched with availability, and working tables are prepared for the years of the data which is available for storage projects, inflow data, I mean to say, what is the water availability data. So demand is to be matched with availability of water. If it is storage projects, they are matched on monthly basis, and if it is a diversion projects, these 10 daily demands are to be matched with 10 daily availability. Now as far as success of the scheme, to if we need to provide drinking water demand, then any water which is minimum flow that is available, that would be able to only that much of drinking water needs can be met, because drinking water needs are to be ensured on 100% dependability or 100% success. And for irrigation demands, inflow should be able to ensure that 75% of the time the demands could be met by out of the available inflow. However, if there is a small deficit and subsequent there is a availability, that small shortfall can be ignored, and that can also be considered success to that extent. Now crop water requirement by Penman-Montague method. The details of these methods are covered in a publication number 56 of the Irrigation and Drainage series of FAO entitled Crop Evapotranspiration. Guidelines for computing crop water requirements are available on FAO website. Alternatively, publication titled FAO Irrigation Manual Module 4. This is available on the website indicated here. Now again, the climatological data like temperature, sunshine, humidity, wind speed, latitude, there is a empirical relation provided that is used for computing the reference evapotranspiration. Now the data bank of software ClimVet can be used for computing the climatological data or obtaining the climatological data. So these are the open source softwares, ClimVet for CropVet and the CropVet. So these are the softwares which can very well be used for working out the crop water requirement. Now if we have a look at these softwares, this is ClimVet. If you download it and open it, so it will open like this, and if you click here export selected stations, then a list will be opened. So based on that list you can click on the display of the stations of that country. You will be first selecting the country and then you will be displaying the list. Suppose we select India, then this slide will open and you see the different locations of the India for which the climatological data is available in ClimVet and would be provided for computations, and accordingly the list is also there. So this again you can pick and you can then export the selected stations, and it will ask one station export to the folder. So this uh, would be stored at a location indicated in this on your computer. Now then you can open the CropVet, and from this CropVet software, when you open the CropVet software, it will open like this, and on this you can use the data which is now available on your computer for computing the crop water requirements of that station which you had picked in ClimVet for CropVet. Now as you select that station, because we had selected Amritsar, so as you open Amritsar, the climate ET0 data would be displayed in the software, and see the minimum maximum temperature, humidity, wind, sun, radiation, ET0, etc. So these are the things which would be now ET0 values. So these, and also the rainfall, they will be get picked up from the ClimVet and would be stored in your computer, which can be used by the CropVet software. Now next would be, after climate, next would be rain. So when you click on this, you open and you get the rainfall data and effective rainfall data for Amritsar. So this rainfall data would be used for computing the crop water requirement, and the rainfall method used by the software is USDA method. Next we move to the crop. When you click crop, then you have one open, and then when you open this data, there is lot of data of crop data is also available on the CropVet software itself. So based on the crop which you pick, it would provide the data, and accordingly one by one you can pick up all the crops for which you have to compute your data. Then you move on to the soil. So soil also you can select whatever is the soil options are there. So you pick the soil, right type of soil which is applicable to your area, and then there are certain predetermined values. If you have certain data about your soil, you can change it. Then next is the crop water requirement. So this will give you the crop water requirement of the crop which you have picked. So this way you can find out crop water requirement for all the crops which you are going to use, and then this is the cropping pattern. So here you provide the crop file and what are the crop names, plantation dates, harvest date would come, and what is the area out of your total command area which you are going to pick out of it. And then when you move to the scheme, you get crop water requirements at different times corresponding to different crops, and what is the net irrigation requirement, and what is the area for which you are providing the irrigation. So this is how you use this crop wet and clim wet of FAO, and hope you have been able to gather some idea on this computation of crop water requirement, maybe using modified Penman method, or maybe by using this FAO softwares of crop wet and clim wet for crop wet. So you can try them out, you can download the softwares, you can try them out, and if you feel any difficulty or issue, you may very well contact me. I have already given my email ID in this presentation itself. So I hope that session has been useful to you and will help you out in working out crop water requirements. So which is very a basic requirement uh, for working out or planning any system, may it be drip system, may it be sprinkler irrigation system, or may it be conventional irrigation system. So with this, I would thank you all and hope that this session of ours would be of some help to you. Thank you.